what kind of industries are using MATLAB, and colleges also, and how they are utilizing that MATLAB. Okay. So first of all, let's start from applications. And before that, I will like to introduce myself, Akhilesh Kumar. My name is Akhilesh Kumar, Assistant Manager, Application Engineer for MathWorks Products in Design Tech Systems Limited. And Mr. Anup Pandey, he is a MathWorks Sales Representative, MathWorks Product Sales Representative in Design Tech Systems Private Limited. Okay, let's start from application, that what kind of applications we can develop in MATLAB. Deep learning, complete deep learning models we can design in MATLAB. Either you are going to design from scratch, or you are going to use some pre-trained model for your data. So MATLAB supports both way. You can write code, or if you don't want to write code, so some sort of apps are available in MATLAB. We can use that MATLAB to design a complete deep learning models. Not only deep learning, machine learning as well. MATLAB provide a ThingSpeak for cloud computing, for IoT purpose. You can write the MATLAB algorithm directly on ThingSpeak. That is free for students. You have to register on MathWorks, and you can access the ThingSpeak. So MATLAB provide a complete solution for ThingSpeak. Also means like we require to interface hardwares. We can interface hardware in MATLAB, we can work on live data, we can develop our algorithm in MATLAB, we can deploy our model in hardware, or we can log our data on ThingSpeak Cloud also. So depends on you if you want to log on your personal website, or you are going to use ThingSpeak, MATLAB support for that also. Okay. Any participant, or any, if you have any doubt, you can write in a chat box, or chat box also. So whenever I have time, I will reply for that. Okay. You can, if you are working on autonomous system, so complete autonomous system you can design. Doesn't matter it's from automobile, or it is some kind of hardware you are designing, any kind of product you can automate there in MATLAB, and you can create animations also, like which you see, right? So if you are working on automotive, you can create such kind of animations, and you can check that how your vehicles are behaving, right? So we can animate also. If I am talking about automotive, we can design conventional vehicles also, electrical vehicles also. We can design hybrid kind of vehicles also. So depends on you that on what kind of application area are you working, and you can use MATLAB. So we have certain modules available, like powertrain block set for vehicles, vehicle dynamics toolbox is available there, drive line is available there. Automated driving system module is also available. Somebody want to design advanced driving assistant, that is automatic driving system. Robotics. In MATLAB, you can interface real robots also, or you can design this kind of robots also. These are manipulators, right? So you can design this kind of manipulators also, and you can design a complete robots also. You can interface with real robots also. So we have toolboxes available in MATLAB. Robotics toolbox is the robot operating system, ROS, which we use to interface real robots. Okay. So either you are working on mechatronics, you can design a complete mechatronic system also, or you are working on conventional energy or renewable energy. So that kind of models we can design, or somebody is working on grid system, that is possible. You can design with MATLAB very easily. So MATLAB is a language for engineer and scientists, or somebody is from MBA. You can design whatever you can think, you can design in MATLAB. Aeronautics, somebody is working on aeronautics application. So complete dynamics of aeronautics we can design in MATLAB. So we can create a animation like which you see here in the figure, right? That what is the landing time, what is the departure time, and what is the dynamics when it is landing, right? This complete things we can automate using MATLAB. These are some companies which you see they use MATLAB, like Airbus is there, Boeing Boeing is there, right? Apart from that, Volvo is there. Lots of companies are there. These are from aerospace and defense. If I'm talking about Indian company, DRDOs, they use MATLAB. Or if I'm talking about ISRO, they use MATLAB for their some applications. So these are some companies from aerospace and defense. And there are lots of companies when you visit on MathWork website, you can get that. These are consumer electronic companies, Philips, Harman, Teclifon, Realtek, Epson. They use MATLAB for their some applications. They in consumer electronic industries also. Industrial automation industry. So there are lots of jobs available in automation and machinery industries. Even if I am talking about Indian company like Tata, Mahindra, right? Or if I am talking some companies like Tesla, if you heard about it, right? So any big company, any automation company, they use MATLAB for model-based design, right? Or these are the some other companies they are using MATLAB. So what I want to say that this is a very professional software, and if you know how to use MATLAB, so you will have a lots of opportunity to go in big industries and big companies. These are some other industries which you see BMW, right? That is automotive industry, right? Mercedes-Benz is there. Honda is there. This is still automotive company, right? A big semiconductor company that is ASML, right? Virtual Metrology Technology. They use MATLAB for their some applications and in this such kind of industries also. Now, if I am talking about top 200 universities of the world, they have a MATLAB and they use MATLAB for engineers and for their students. And if I'm talking about Indian colleges, so lots of private colleges, they use campus-wide license, means unlimited license they are using, and it is fully access for everyone. And if I'm talking about IITs and ITs, mostly everyone has a campus-wide unlimited license and lots of applications. They use MATLAB for to design their lots of applications because it's very easy in industries also. It's very easy to access MATLAB and do everything from end from start to end, means from designing to production. We can design the complete model here, and various kind of testings also we can do in MATLAB. Because before going to launch commercially, we require to do various testings we can do in MATLAB very easily, right? This is a case study of one college that is VPKBIT. It comes under Pune University. So the challenges which they were facing, because the challenges were that students were from rural area mostly. They wanted to educate with that software which works in the industry. This was the challenge. So, and they wanted a cheap software. I mean, not very expensive that which cannot be accessed for every students, right? So MATLAB provide they purchase the wide license. Campus-wide license is very cheap and unlimited license are available there. Anyone can access anywhere, online, offline, depends. So they procured this license, and the outcomes here you see that they access to industry standard software, provided awareness of technological mega trends. Whatever the new technologies are going on in industry, MATLAB always update that algorithms in their software, right? So lots of interactive online training courses you will get free, right? With the campus wide license, and you can motivate students also, and students will be self motivated in that case. Lots of courses free available, as well as that courses when you are going to complete you will get a certificate as well in that case. So this was very good case study from VPK BIT, and they were able to train the rural students also with the industry standard software. Okay, we'll start from brief history of MATLAB, how MATLAB was designed. So first of all, origin of MATLAB was series of research papers. There were 18 research papers which were published. Second, in IcePack and LeanPack, they published some papers. They showed the application of MATLAB. It was written in Fortran language. For the Lee Moller, he is a founder of MATLAB. He created a matrix calculator. Okay, he created a matrix calculator and it was written in a Fortran language. This was the first MATLAB as a matrix calculator. That's all. And the code which you see, it was like this. That is a Fortran language which they have used. Commercially, MATLAB was launched in 1985. The first MATLAB which was launched commercially, it was 1985. So from 1985 till now, MATLAB is very widely used, right? Everywhere they are using MATLAB in industries and in engineers. It is a software of the engineer, we may say, right? So this is about the story behind the logo of MATLAB. The logo of the MATLAB was taken from a thesis that was based on L-shaped membrane. So this was the first logo of MATLAB, which you see here. And year by year, the changes of logo was like that. In 1984, then 1987, 1992, 1994, 1997. The logo which we see in 1997 is still it is used in MATLAB. Right? This is the still we see this logo, right? This was the modification in the logo here. Okay, this is our agenda, which we are going to see. Introduction to MATLAB, demo on fuel economy analysis, introduction to MATLAB environment, building analysis routines, creation document, how we can create documents, and how we can create an app if I want to share with my colleagues, means like a .exe file kind of thing. So here the data which we have, that is fuel data we have. So we are going to make a relationship between horsepower and mileage. So what we will do, that let's say this is the horsepower of the car or truck, then what will be the mileage of the car and truck. And also we will take in consideration that that car and trucks are driving in the city or on the highway, because mileage is dependent. If it is in the city, mileage will be low, right? Because lots of traffic, lots of brake. If it is driving on the way, then mileage will be high of the vehicles, right? So these considerations we are going to take here. Before that, let me explain the MATLAB, that what is MATLAB again. So MATLAB is a high level language, like the mathematical equations which you write in your notebook as it is you can write in a MATLAB. So the functions are very user friendly. You need not to require to remember anything. MATLAB gives suggestions. If you have any error, MATLAB will let you know. You don't require to remember anything in MATLAB. Once you start using MATLAB, automatically you will remember. And MATLAB, as I told, MATLAB will give you a suggestion that what function you require and all that things, right? And there is documentation for every function in MATLAB. So you don't require to do a Google or anywhere. Once you install the MATLAB, you will get the documentation for everything. Okay. Interactive development environment. So MATLAB is interactive. It's not like just your coding only. So you can use apps. You can visualize your figures also, right? You can design your apps, or you can use your apps. You can use for numerical computation. You can use MATLAB for data analysis, visualization, algorithm development. So any kind of algorithm if you want to develop, so you can use MATLAB as a programming language, and you can deploy in a hardware also MATLAB. So depends that where are you going to deploy, on machine, on hardware, or .exe file, depends. Or you are going to generate library for other languages. That is also possible, like for Java, C++, or Python packages, let's say. So we don't require to write or code in different languages. We will write in the MATLAB and we can generate libraries for other languages also, library and packages. Okay. This is a MathWorks product family which you see, right? So right now there are around 115 toolboxes available in MATLAB. Depends on your application area. In which application area are you working with, you can use MATLAB. Let's say if you are from electronics communication, you can use signal processing, you can use image processing, you can use communication, you can use 3G, 4G, 5G modules are available. Even 6G modules are also available right now. So you can design complete communication. Somebody is from finance, let's say, so there are financial toolbox available. Somebody is from MBA, they can use trading toolbox, financial toolbox, that modules are also available there, right? So MATLAB work two way. So first way is that if you want to write a code, you can write a code in MATLAB, or if you want to design your algorithm as a graphical way, right? So we can use the blocks also in Simulink. Instead of writing code, we can use blocks. Okay. And the applications of MATLAB like control system, signal processing communications, image processing and computer vision, test and measurement means if you want to log data from hardware, so you can interface instrument kind of hardware also, instrumentation kind of hardware like CRO kind of hardware, right? Somebody is from biology department, so we have bioinformatics sim biology available. So bioinformatics is used for the biological data analysis, sim biology is used for the drugs dose designing, right? So even if I am talking, you heard that Pfizer has their own vaccine for COVID-19, right? So they use MATLAB to design some part of that vaccine, not a complete, but they use MATLAB to design the some part of that COVID-19 vaccine, Pfizer company, right? So either you are doing mathematical analysis, you can do. And we have a group for code generation also. So we can generate different kind of codes also like PLC code, C++ code, embedded code, STL code, Verilog code in a single click. You don't require to write that code in that language. You can generate and debug also that if there is some kind of error, you can correct and MATLAB will let you know that where that kind of errors are available there. Okay. So this was the goal which we are talking about. So studying the relationship between fuel economy, horsepower, and type of vehicles. The type of vehicles we are going to use car and truck. Approach how we are going to follow here. Access data from Excel file. The car data or vehicle data we have that is in Excel file. We will visualize our data. We will do some kind of data analysis. Then we will create a predictive model to predict the mileage in this case. Okay. So this process we are going to follow. If I am working on data, MATLAB works like this. We will have a data in a file, or we are going to log data from different software vendor, or we are going to log data from hardware. So MATLAB work on live data as well. We can log live data from hardware as well. Once we have data, MATLAB have lots of functionalities to do a data pre-processing. Why? Because when we log the data, maybe there can be some noises. If we log data, maybe there can be some spikes, unwanted data, maybe there can be some missing data. So this kind of things we can do very easily in MATLAB. So we'll see how to do that things also. I will show you demo also. Then you can develop the algorithm, and further if you want, you can design the apps also, or you can share your MATLAB with as a PDF doc file, or if you want to publish on website, you can generate a .html file as well. Either you can deploy in a hardware, or you can create libraries for other languages also. If you are working on big project, you want to interface MATLAB with other languages, we can generate the library for other languages also. So right now I am going to switch in MATLAB, and just 1 minute. So before we will go for that demo, we will see some basics of MATLAB, that how we can use capabilities of MATLAB, and we'll discuss about everything MATLAB here. Okay, so this is a MATLAB command window. Okay, or you may say this is a console also. Let's say I am going to define some values 1 to 10 here. It will be displayed here, right? Once I executed this, you see that this variable appeared here. So that is called workspace of MATLAB. Any variable, if I define anywhere in the MATLAB, once we execute that, it will be appeared in the workspace. And this is the current directory of MATLAB. Okay. So this is the current directory of MATLAB. So when you save any data, any file, as a default, it will be saved in a current directory. Or if you want to load any file in MATLAB, it has to be in a current directory. So this current directory, you can change from there. And here we have some plot options available here, right? So let's say that I have this data here available, and I want to do a quick visualization of this data. So simply I will select from workspace, and when I go, Whatever supported plots are there, it will be appeared. This is a simple line plot. And if I click on this is area plot. This is the bar plot, right? And further you see this is the pie plot of that, right? Stem plot. So that's very easy to do, right? And here you see that if I have to do these plots by command line, just simply I have to give this plot for plots. No need to remember, right? Area, bar, pie, stem. So this kind of plots we can do very easily in a single line in MATLAB. One thing more, let's say that you want to do some uh, algorithm development, and maybe you don't remember that function. Let's say that I have to find out the correlation between two data, but I don't know what is the function. Simply you have to click here, fx here, you see, and simply I will type the corr, just few letters only, and based on this letter, whatever the folders and files are available, it will be shown here. So you see here, these are the folders by this name. And here you see that there is a linear or rank correlation. And you see that if I have to find the correlation between two images, I can use this function, right? So just search here and you will get the help also. Another way to get a help, just click here, and here you see that whatever the modules are available in MATLAB, it will be here, right? And you see here, somebody is from math departments. We have a curve fitting toolbox, deep learning, optimization toolbox, partial differential equation, machine learning, symbolic math, symbolic math analysis. If you want to do, we can use symbolic math for that, right? Somebody is from communication. So we have 5G toolbox, antenna designing, communication toolbox, LTE for 4G is available, right? DSP system toolbox is available, right? Wavelet is available, right? And somebody is from MBA, let's say. So there is a financial toolbox also available, right? So we can use computational finance toolbar like database. If you have different database like SQL or Postgres SQL or different kind of database, so we can use database to extract data from the other database. Data feed is used to extract data from online financial data online, right? From all econometrics is there. Somebody is working on economics data, right? Financial is there. So lots of options are available, lots of modules are available here, like computer vision, MATLAB. Let's say that somebody is working on computer vision, and I don't know how to use computer vision. So just I will click on this computer vision, and you see that there is an option for get started, right? So if you are a beginner, just click on the get started and complete all these links which are given there, and you will be aware that with this module what you can do with in MATLAB. So for every functions, every modules, there is a get started, right? Okay, and here if I go here in function, let me do back here, and if I go in the function, and you see whatever the functions are available in that toolbox, it will be shown here. Let's say that I have to extract the features from images. Just I will click on this function, and you see here we have an option syntax, how to provide the syntax, descriptions of that, right? Examples are also available that if I have to extract the feature, then how I am going to use. So there is the examples. You can use that examples for your reference, right? So for every functions, here offline documentations are available. Fine. Let's start from some equation designing. Just 2D and 3D equation if I have to design. If I have to represent in MATLAB, how we can do, then we'll go for that demo, right? So we'll start from the very basics right now. Okay, I am going to use live script here. So you will see the capability of live script in new MATLAB. Okay, here I am going to write a code. And we are going to do a 2D and 3D plot in this case. Okay. So let's say that I have to write some comments here. First of all, there is the option choose the text, and I'm going to write 2D and 3D plots. Am I audible?
Yes, sir, you are audible, sir.
Sir, we lost the presentation also.
Yes, ma'am. They are again connecting.
Okay, sir. Thank you.
So request you please wait for a moment. There is some problem, technical issue at Achilles side. So he's rectifying. Soon he will attend you again.
Okay, sir, no problem.
Am I audible right now?
Yes, sir.
Yes, Achilles.
Okay.
Now
Yes,
you are.
audible.
Yes.
There was some internet issue, so just I was checking
No,
what happened there.
no issue.
1 minute. Okay. So we are discussing how to do a 2D or 3D kind of plot. So we were going to start from the basics. So if I have to write a text in the live script, just I selected 2D and 3D plots, and let's say I want to give some heading also here. So like this, we can give a heading as well. And let's say start from the 2D plots. So simply I can write 2D plots, and I can give, we can format this, depends on you that how we are going to format here. And let's say I have to design some kind of equations, and I want to write an equation as a text. So there is an option. So you can choose simple equation or latex equation. Let's say I'm going to choose the latex equation. Y is equal to A into sine T, some kind of equations like this I am going to design, and you see that this equation appear here, right? Now I am going to design one signal here in MATLAB. I am going to choose port from here. Okay. My voice is coming proper or is still some issues?
So it is coming proper.
Just 1 minute. I think Wi-Fi internet has been come.
No,
So let.
your voice is clear now.
Clear, sir.
Okay. If there is any issue in my voice, let me know. So I will change the internet. Okay.
Sure, sir.
Okay, sir. Okay.
Fine. So this equation we are going to design, and we know that this is a periodic signal in right. So if it is a periodic signal, we have to define for sampling, frequency of the signal. Let's say frequency of the signal is in hertz. So percentage sign we simply use to write a comment here also. So we can write comment like this also and like this also. We require to define the sampling frequency also. Let's say sampling frequency is 100. Now we require a sampling time, right? So here I am going to define the sampling time. It will start from 0 and 1 by fs will become a sample time, right? So 1 by fs, and let's say that for 5 seconds I am going to design the time. So this is the start and this is the step size and this is my last value. So this step size can be a sampling frequency also, 1 by fs, right? And here, let's say I have some amplitude also. So I'm going to give amplitude as a 10 here. Now I'm going to design my equation here. Y is equal to A into sine. So for the multiplication, we use this asterisk sign here. So this is for the multiplication into 2 into pi. Pi we denote in MATLAB with pi into that frequency of the signal and into t. So this is our signal, right? And simply to plot it, plot t is the x-axis and y is the y-axis. So if I run here and we'll get the plot here, right? This is the perfect sine wave which we are getting, right? Okay, let's say that if I have to teach students or if I am a student, I want to check my signal on different frequencies. So we have two options. Manually, we can change this or we can use the for loops also. So instead of changing manually or using for loop, we can use some control tabs here that you see here. There is a numeric slider, right? I'm going to choose this numeric slider and I will double click on this. Here I can define what is the my start frequency, what is my end frequency, and what is the step size of the frequency, right? Once I have provided that, this sine wave I am getting when signal frequency is 3.2, right? Let me increase this frequency somewhere 35 and this is the sine wave. And now you see that this sine wave is distorted. The reason is that we know the rule. If I have to sample or signal, sampling frequency have to be double of the signal or more than that. That's why this is distorted here, right? But once we decrease this frequency, we will get the proper sine wave here. That's the complete proper sine wave, right? Okay, now this is about the 2D plot. Next, I'm going, and you see that once I executed this section, I don't want to execute this section again. There is an option for the section break. And I am going to choose text here. And simply I am going to write here 3D plot. Or let's plot the helix here. 3D helix plot. Okay. Now I am going to write a code. I will choose code from here. Okay. So for a 3D plot, we require a x-axis data. We have this. We require y-axis data. We have this. Now we are going to define a z-axis. Let's say this is cos t. Very simple. That is cos t, or we can simply 2 into pi into f. That also we can do, right? The complete periodic signal we have here, right? Now plot 3D, we use simply plot 3. That's very simple. And here we'll provide the x-axis data, then y-axis data, then z-axis data. Also, I want to give the label also on x, y, z. Simply, and you see here a few letters I am typing and MATLAB is giving us suggestions, right? So I don't have to write manually completely everything, right? So on x-axis we have sine. Simply I'm going to write this, then y level. And you see that we got again suggestion from MATLAB, right? This is cos. Sorry, y is sine here, right? And x level is time, right? Okay, and z. So z level. So we can give the level also here. And this is cos. And I want to give the title also. So let's say this is helix, right? And I'm going to plot this 3D one. And you see that perfect helix we got here, right? and on x-axis is time, y-axis is this, and cos-axis is this. So any kind of equation you can have, you can design like this. See, this is my equation. Let's say that I want to modify this equation. I have t square also. So we use like this dot cap this and t square, right? And let's say I have here cos t also, something like that, right? So this y is changed right now. So by this graph will be also changed from here, right? Based on the equation. So any kind of equation we can write in MATLAB very easily. And here we can use the slider, and now frequency is 21. This graph is changed. And once I will execute from this left side, when I click on this strip, this figure will be changed from here, right? Because now frequency is 21. So there is an option to run a section here. Run and advance option is there, right? So once I will click on run and advance, first will be executed, then it will reach to the second section. So like this also we can run, or if simply I will click run, all sections will be executed, or we can select any section and here we can click to execute in the left side. Apart from that, whatever I have done here, if I want to create a document for that, simply I will go save as. And in the save as, we have an option as a PDF, as a doc, as the HTML or latex. So simply I'm going to choose here, let's say doc. And once I will click this, and I will get the doc file of that, whatever we have done there. Okay, I have one question here, that this slider option is available in the lower version or not. So slider option is not available in the lower version of MATLAB. I think it was introduced from MATLAB 2018. So if you have a 2018 or higher version, so we can use the slider. And you see here that we have a proper doc file. So if I'm writing a thesis or if I'm making documentation, we have these options. One thing more, let's say that I want to share this algo with my colleagues, but I don't want to share my codes. I want to share just figures only, outputs only. So in that case, there is an option here. You see, right, hide the code. We can hide the code, and again we can go in save as, and we can, once we save it, that code will be hidden. So there is an option here available here, right? Or we can plot it line by line like this also. That's very good for teaching, if I'm teaching students or if I'm giving some presentations also. So it's very good for interactive classes also if I am using live script, right? Okay, so any questions if you have, you can ask me. Okay, so I'm going to close this. I'm not going to save here. I'm going to close this here from here. No. Okay. One thing more here. Let's say that if you want to do some mathematical analysis in MATLAB. Okay. So in MATLAB, we have a symbolic maths available. So let's say that I have some equations. I have to integrate or differentiate, or let's say I want a Laplace of that. Very simple. Whatever I want, whatever the mathematics or matrix is available, I want to do that without data. So whatever symbols I am going to use in my equation, just I will define it here. Okay. Now I am going to write my equation. Let's say I'm going to write a simple equation z is equal to sine x. I want to Laplace of this. So simply the function is Laplace. I think it is changed. Let me check that of z, and I will run this. And you see here. Okay, just 1 minute. Let me here clear everything, because x was already defined in the previous one. So I'm going to just change that. And here I am going to provide the x. As I told, whatever variables I am going to use in my equation, we have to define as a symbol using sims, right? So now you see that we have a Laplace of that very easily. And whatever this Laplace I am getting, let's say I'm going to save it as a, and then I want to take a I Laplace. You see that we got this function here from MATLAB and A, and again it will be converted in the form of sine wave. That's very easy, right? Okay, I'm going to do a section break, and again I have symbols x, y. Let's say I'm going to write one equation again, x into sine x plus y into cos, sorry, x into sine x, oh, perfect. Y is equal to, let's say it is cos x. Okay, let's say I want to differentiate this equation, let's say, and I'm going to save as a d. So simply in MATLAB, we can use diff of z with respect to which variable. Let's say I want to integrate with respect to x, or simply I will run this and I will get the differentiation. Let's say now I want to differentiate d with respect to y now. Perfect. And here you see that a we have a z is equal to sine x we have here. Let me do a section break. Z is equal to sine x. I want a Taylor series of that. Simply, and you see just few letters I have written here, and we got this function from MATLAB as a suggestion of Z, right? And in a single line, we can get the Taylor series. So any kind of mathematical calculation, differentiation, integration, we can do very easily. If I have to integrate this, that this sine x, I and t we will use here. See here, I and t, and simply I can write z integration with respect to x, and we will get the integration minus cos x, right? Okay, somebody is asking few example for finance. So let's see if we have time, then we will see some examples finance related also. Okay. Or later, if you have session on machine and deep learning data science, so we can show some demos on financial also. So don't worry, we are going to use data. Same way you can use data for financial also. Just you have to change that data. So need not to worry for that. Okay. Okay. Here, what I'm going to do here again in the section break. Let's say that I have to solve some equations. For example, let's say I have some polynomial equation here. I'm going to just write a polynomial equation. Let's say it is a into x square. Okay, this is my equation, and I want to solve with respect to x. And this bracket close here. So simply we can write here solve equation with respect to x. Depends on you that in what respect are you going to solve it. Now you see we got error here. So I wanted to show you, if you are getting error, MATLAB will let us know. In this case, you see that B is unrecognized because A, B, and C are not defined here, right? So we can create a symbols of A, B, and C. Now we will not get there because we have created the symbols, and this is the x value, right? It is quadratic equation, two values we are getting. Or instead of solving this equation, let's say I want to solve with respect to B, right? And very easily. Now the output is, this output is with respect to B. So this is the demo that if you want to do some kind of mathematical analysis, you can use symbolic math in MATLAB. You can create the symbols of that variables which you are going to use in your equations. Okay. And then you can integrate, differentiate, or different kind of series, Z transform, Laplace transform. You can do it very easily using symbolic math, right? Fine. Let me clear everything from here. How to import data in MATLAB. Now we are going to discuss how to import data in MATLAB. Okay. So here I have some data available here in Excel file, you see, right? These are the car data. Let me open this data outside of the MATLAB. First of all, let me show you that what kind of data do we have here. So here we have the Excel file available, and you see that we have years and we have data if it is a car or truck, right? And this is the engine. display. And if I go more here, you see that what kind of fuel type is there. And you see that we have a mileage available, right? And we have the rated horsepower. So we are going to use vehicles, the rated horsepower, and we are going to use the mileage from here. And what is the CO2 and CO emissions from there? Am I audible?
Yes, sir.
Am I audible?
Yes, sir.
Okay, fine, fine. So screen is also visible, right?
Yes, sir.
Screen is visible, right?
Yes, sir. Yes, sir.
Okay. So I have data. My data can be in Excel file. My data can be in text file. In any kind of file format, I will have a data. And let's say I want to do a data analysis. First thing is that we have to import that data in MATLAB, right? So I am going to choose this Excel file data. Okay. Uh, so let's say I don't know what is the function to import data in MATLAB. So here we have an option for import tool, right? I'm going to choose this import tool here from here. A new window will be opened like this. Now, here you see it is shown that what kind of file formats we can use to import in MATLAB using this tool. So you can see JPG is there, .icu is there, GIF is there, text file is there, dat file is there, right? In our case, we are going to choose just one Excel file from here, and I'm going to open this. Here we have this data, so it's taking little time. And now you see we have a numeric data, we have character data also. If you have such kind of data, mixed kind of data, numeric and characters data, we are going to choose to import as a table. Perfect. And here you can select also what portion of data are you going to import, or select all, depends on you. And I will click on this green tick. And my data is imported here in MATLAB. See, I have this data, and in data, we have multiple columns available. Let's say that I'm going to extract the rated horsepower and the mileage of the car. Okay. So simply, let's say I want to import the rated horsepower. First of all, so this is my table name. Simply, I will give the table name. I will press the tab here, and whatever columns are available, it is visible, right? I require a rated horsepower. Yes, I will select that, and I have here rated horsepower. And you see that we have that column that is rated horsepower. So we have this horsepower, right? We have one missing data also. Manually, if you know the value, you can fill it also like this, right? It is filled here. Okay. Next, I am going to import here mileage. So again, this is the table name. Dot mileage column name was MPG. We have this also, right? Now I am going to do a scatter plot of this. A scatter plot of this mileage with respect to horsepower. On x-axis, we'll have a horsepower. On y-axis, we have a mileage, right? And you see here, by this figure, you see when horsepower of the car is increasing, then mileage is decreasing from this, right? So some kind of curve equation we can create here like this. So we are going to fit this data. Also, we saw that mileage is inversely proportional to the horsepower. When you are increasing the mileage, horsepower will decrease. When we increase the horsepower, then mileage will decrease by this figure, right? So perfect. Okay, so we got how to import the data in MATLAB. One thing more I will like to tell, for the automation purpose, we can generate the code also for that. Let's say I am going to generate the function here, and this is the function file, right? Before what function we have used, like in our equation, we use the sine and cos kind of functions, right? So this is the user defined function. I can save this function somewhere by this function name. This is the function name, right? Once I have this function, and just simply I will use that function, the function which I have created. Sorry, some issues is there. Just let me check that. Okay. Okay, it is saved here. Okay. So simply I will use import file, and this is my function. And here I will just provide the file name, whatever the file I'm going to import here. So here we can just use these file names. And when we execute that, I will get the table in MATLAB. So two ways we can use this import tool, or we can use the generated function to import that data in MATLAB, right? Okay. So let me open that example which I have here available. Okay, it is available here. Just 1 minute. So first step is we are going to do some analysis. Fine. Here you see that I have already created a function, and I'm going to import Excel file that is by 2007, right? Just I will click on this. This data will be imported here. And if I switch here in MATLAB, and you see that we have this table here, right? We have all this table. Fine, perfect. Now I want to see the summary from this table of rated horsepower column, of mileage horsepower column, and carbon dioxide. Okay, CO2. So I want to see the summary of that. Simply summary. This is the table name, and these are the column names. So in a single line, we can see the summary of that. So here in the summary, you see what is the minimum value of, what is the maximum value, what is the median value of rated horsepower, same for the mileage and CO2 also. That's a very easy to do here. Perfect. Next, we are going to create a figure. I mean mileage with respect to rated horsepower. Let me run this first of all. And I will show you how you can create your customized figure in MATLAB. So right now, this is the figure which you see here, right? How to customize this figure? Here again, we are using some kind of functions here, right? Let me show you how to customize this kind of figures. What I am going to do, I am going to do a scatter plot. Okay. From this car data, on x-axis, I want it will be the rated horsepower. On y-axis, I want mileage. So that is MPG, and I'm going to plot that. And let's say I am not happy with this figure, the figure which I see here. I want to modify this figure, and I want to make bold this axis also. So simply I will go in the view, and you see there is an option for plot editor toolbar. Just select this, and you see that we got the editor here, right? Different editor available here, right? Options we got. Another, if I go in the view here, you see there is a property inspector option available here, right? This property inspector we can use to modify our data. Like let's say I want to make this axis bold. Simply I will click bold, and it will become bold here. So it is still processing. Just wait for a minute. Okay, now you see this is a bold. I am not happy with this color. Let's say I am not happy with this color. I want to change the color of this. So this is a property inspector, and just I selected this graph from here, and I want to change the color of this. Just so you have to select this. Okay. Once you will select, this will be opened, and marker face color. Let's say I want to give the red, and you see that these colors are changed, right? I am not happy with this circle color. I want to change the marker also. So here is the option. Different markers are available. Let's say I want a diamond kind of marker, and now you see we have a diamond kind of marker. Okay, I don't want this line width. I want to increase the line width also. Let's say it is 2. And now you see that line width became 2, right? I will close this. Once I am happy with this, I can generate the code. Code will be generated. Save this code as a function file. give the x-axis data, y-axis data, and you will get same customized figure here like this, right? We can modify that. And further, if you want to save this image, just click on save as, and there are different options available. Depends on you what kind of file format are you going to use. You can save this also. Okay, so this was about the customization of figure. And here I have already created that function. I just am giving the input argument. So x-axis data and y-axis data, and we are getting this figure, right? Perfect. Okay, one thing more here. If I want to apply a relational operator or logical operator or mathematical operator on text data, we have to convert in a category. Remember this. So in this table, if I go here, this car truck data are characters. We have to convert it categories so we can apply the mathematical operators or relational operators or logical operators here. So here to do that, there is a one function categorical in MATLAB. Okay, categorical of this column, car data is the table name, and this is the column in that table. I am converting in a category and I am saving it as also as a category here, right? So it will convert it will be converted as a category. Now, also one thing more here, one more column we have here. Let me show you that column here. That is city highway. It's showing that if a car or truck is driving in the city or highway. Okay, I have to apply relational operator here. Okay, that's why I am converting in a category. Fine. I am going to execute this part only. I will select right click, just evaluate that, and it will be executed. Now you see what I am doing in the next step. I am going to extract the index from this column where cars are written, only car. So if I run this, let me show you what we are getting. We have two kind of vehicle, cars and trucks. Once I executed and we got the logical index. 0 means there is no car. In that column, in that row, there is no car. 1 means there is car, right? So if I give the sum of this car ID, it will let me know how many, sorry, spelling mistake. So it will tell me how many number of cars are available there. Perfect. Now I want to see how many trucks are there. Truck samples, right? Instead of this, I will just simply type truck, right? I will get logical index. Wherever there is truck in that row, we will get 1, else 0. Then I will do a sum of that. And we'll get the total number of truck samples available. So same thing we are doing here. Okay. Now you see what we are doing. We are extracting the data. How? If a vehicle is driving in the city, that index, and this is the AND operator. And if it is a truck, means I want that ID if truck is driving in the city. So very simple, car dot city highway, that is city, and this is a truck, right? So here we will get the index of trucks which are running in the city, right? Same way we can do for both city and highway. So these are the IDs how we can extract using this relational operators. Perfect. Relational as well as logical also. This is logical operator and these are the relational operator, right? Okay, once we have that, we are going to do a distribution plot here. Let me run, explain, and then I will show you how we can do a distribution plot in MATLAB. See this graph, this distribution. Okay, so this color which you see, that is a magenta kind of color. It is showing city. The green color is showing highway. The red color is showing city, and again this blue color is showing highway. And the plot which you see, it is showing that how data is distributed. Okay, how the data is distributed here. And what we are plotting, mileage. See, MPG. We got the city IDs, we got the highway IDs. What we are doing? We are checking the distribution of the mileage if vehicles are driving in the city and in the car on the highway. So from this distribution, what we can see, you see that this color is showing highway, right? So if a car is driving on the highway, then the mileage is high. If it is driving in the city, the mileage is low. See, the value is high, right? This plot is showing, right? So how to do a distribution plot? We don't have to write a single code for that. Let me show you how to do that. First of all, let's say that I want to do a distribution plot of. So this is very important for management also. If you are from management department, right, you can use your data to get the distribution plot, right? So car data, mileage, horsepower is saved as a rated horsepower. We have, I want to see the distribution of this rated horsepower. I am not going to write a code. I am showing you the app capability in this case. I will go in there. This is part of machine and deep learning. So there is one, no, it's not showing here. Here we have in the math, statistics and optimization, there is a distribution filter. Okay. So that's very important. If you are working on the sample data, your data should be normally distributed. Remember, that is the logic here when we are working on the sample data. If it is not normally distributed, we convert in a normal distribution. Okay, so first thing, I have to import data in here, right? Simply I will click here data. And data we have here in workspace, right? I'm going to select that data, that is horsepower. If you want to do censoring, means removing some data, you can provide the index which you are going to remove. And you can provide the frequency, means if some data are occurring multiple times, you can provide the frequencies also. In our case, we are not going to do anything, just I'm going to create a data set. So once we have this data set available here, I'm going to close this. And this is the histogram of my data. Again, it's showing the distribution. Next step is to fit this data. I am going to use new fit. Okay. Once I will go in new fit, there are different kind of distribution fit functions are available. So we can choose. You see, there is a normal distribution, exponential distribution, different kind of distributions are there. I am going to choose normal distribution. I am going to apply. And you see that this is the normal distribution. We can say that it is normal distribution and more it is shifted in the left side. So it is called T statistics. If you are a mathematician, then you will know what is the T statistics here. Or T student statistics also will say this is skewed in the left side. Okay. Okay. Now, for this normal distribution, what is the mean value? What is the variance here? What is the again mean value? What is the standard deviation? All things are given here, right? Okay. I am not happy with that distribution. Let's say I'm going to try different distributions also. Again, I will click on the new fit. I can select different distributions also. I want to check with other distributions also instead of normal. Let's say I am going to use logistic distribution and I'm going to apply. So you see here we have one logistic distributions also. Okay, let's say that I am happy with the logistic distribution. I will go in the manage fit. I can untick that normal distribution from here, right? And I'm happy with this distribution. I can see how data is distributed. So on y-axis, it is showing number of samples. On x-axis, value of the samples. Okay, so I can say that at value 200, how many number of samples are there here available, right? Next, once we have fitted this data, there is an option for evaluate. So if I click on this, and I want to check that I have some data available here, I can write it, let's say that 200. I want to check this data exists in this distribution or not, in this population or not, in this sample or not. So simply I will apply. Here is the probability. What is the probability that it exists in this distribution? Perfect. And further, we can generate the code for that. That's very simple. We have generated the code. The same code that which I have generated, I am using here. Okay. I'm going to, and this is plotted here. Now Z scatter plot, that is called group scatter. Okay. So it will group your data based on the grouping which you have provided. So here you see what is happening here. I am, first of all, I am going to do a scatter plot of mileage with respect to rated horsepower. Perfect. This is a, okay. Now I am going to do a grouping based on if a vehicles are car and truck and if they are driving in the city highway. So these tables we have, right? So once I executed that and we got this, see, if car is driving in the city, this red color is showing, right? And this light blue which you see, if a truck is driving in the city, what it is showing you that if truck is driving in the city, then mileage is very low. You see, this is lower, right? And if car is driving in the highway, that is green color, mileage is very high. That's what I was showing you. So this analysis are very important to get the insight from the data. And from this plot, Z scatter plot, we can identify that car is driving in the city, then what is the mileage? If car is driving in the highway, then what is the mileage, right? Either it is high or low, right? We can compare that using Z scatter plot. Now we are going to fit our data. Fine. So let me show you how to create a mathematical equation for that data. I'm going to close all these things. Simply, I'm going to show you how to create a mathematical equation for data. Okay. So horsepower we have, and I want to extract the mileage. Okay. So we have here a rated horsepower, we have mileage. We are going to create a mathematical equation of mileage with respect to horsepower. Okay, so mileage is by target and horsepower is input. Perfect. Mileage is output or target and horsepower is input. Now we are going to use least square linear method or non-linear method. Both options are available. Right now we are going to use curve fitting. Fine. So I am going in app from here, and there is a curve fitting app available. So instead of writing code, we can use this curve fitting app to fit our data. Why I'm showing you this? Because let's say if you're a beginner, you can use these tools, you can generate the code and you can understand what is going on behind that, right? So X data is horsepower and Y is mileage. Only two variables we have, right? One independent, one dependent. Okay. Now, if you have your custom equation and if you have to estimate the parameter, you can choose, you can write your equation here. Perfect. Now, there are different kind of equation. Let's say I am going to use polynomial. Okay, I am going to center this also. What kind of robust model I want? I can choose from here. That is optional. Okay, now you see here, there is a fit option. Maybe you will have some limit of your parameter, lower and upper limit. So you can provide it here. What will be the lower limit? Let's say it will be 0. You can provide the 0 also. Depends on you. If you have a lower and upper limit, you can provide the limit also, right? Okay. And here you see, once I am using a polynomial of degree 1 in this case, and in left side we have this equation p1x plus p2 square. This is a linear regression. Okay. P1 is negative. P1 coefficient is negative, means X, that is rated horsepower. As I told, it is inversely proportional, and that's why this coefficient is negative. Means when we are increasing the horsepower, mileage is decreasing. This is sum of square error. So error very easily you can calculate original output minus predicted output. Take the sum of that. Take the square of that. That is sum of square error. Okay. That is a R square value. R square value maximum will be 1. Minimum will be 0. If it is near to 1, then it is perfect fit. R square value formula is simply original output minus predicted output minus mean of the original output divide by original output minus mean of the original output. So if it is 1 means it is perfectly fitted. But in this case, you see root mean square error is very low. That is 0.23, right? I am going to increase the order of this. And in this case, you see root mean square error increase somehow, right? Or if I am not happy with this polynomial equation, let's say, I will right click. I can create the duplicate. I am going to compare with different equations also. Okay, so I choose this one, and one is polynomial, and another, let's say I'm going to do a different kind of fitting. Let's say it is exponential. Let's say I'm going to choose. So simply I will choose the exponential, right? And here you see we can compare. This first one is polynomial and second is exponential. So in the case of polynomial, root mean square error is lesser than exponential. So we can say polynomial equation is better than exponential, right? Once we have created this equation and after comparison, I can remove this. I am happy with the polynomial one. Perfect. And I can check how this graph is going in the future. Just simply I can increase or decrease the value. I can check it also how it's going in the future also, right? And this is my equation. Okay. Now I want to save this model. So there is an option to generate the code also for the automation purpose. So once we will give the input and output, it will create me a predictive model. Or if I don't want to generate a code, I will select this model. I will right click and I will go to the save. Three outputs we will get: fitted model, goodness of fit, and what are the metrics of that model. Once I will save this, let me show you what three outputs are there. Okay. So first of all, I am going to show you outputs. So this is a matrix of that. Residuals, Jacobians, when least square method is used, right? All these parameters are saved here. Okay. And goodness of fit. So there will be root mean square error, sum of square error, right? Degree of freedom, adjusted R square value, all that data are there. And my fitted model is this. Now, and here we can see this is the equation, polynomial, quadratic equation, and this is a coefficient of the x square, this is the coefficient of the x, and this is the coefficient of constant, right? And now let's see if I am giving fitted model, and here if I provide the rated horsepower, it will predict the mileage of the car. Okay, so we have lots of rated horsepower here available value. We can provide any. Let's say rated horsepower is 300. Then what will the mileage of the car? That is 22 miles per gallon. In this case, it is miles per gallon. Okay, it can be a kilometer per liter. Depends on your data, that what kind of data do you have. You can use like this, right? Or multiple predictions we can do. Let's say that 3002 350. What will be the mileage of the car? And you see this is the mileage of the car, right? I am switching here in the main code. So same thing here I am doing. I have generated the code. Here you see extracted the rated horsepower and the mileage. Fine. And custom equation we are using B1 plus B2 into 1 by rated horsepower. I use that curve fitting tool and I estimated the parameter of B1 and B2. And then I generated the local function. I am just providing the inputs here and it is giving me the fit of that. That's all. So let me execute this and I'm going to execute this section also. And here we will get the fitting. And this is the fitted curve for that. Right. So if you have a custom equation, you can provide the custom equation also. And this is very important. And this is the backbone of the regression, is the backbone of the machine learning. So this basic things we required to know, then we can proceed for the machine learning also, right? So this is the fitting and we have this predictive model, and we can use the predict model predict. So instead of this, let's say that I am telling you, uh, create a predictive model with respect to education and salary. So any idea, I am asking from your side, in education and salary variable, what will be the output and what will be the input? That is very important. We have to choose that what will be the input and output. So you can write here in a chat box, if I have to make a relationship between salary and education, high salary, let's say high educated, high education, let's say high salary. So what will be the target and what will be the input? Any idea? You can write what we have to decide, right? What will be output and what will be input? Just write in a chat box anything. What can be output and input? I have to make one mathematical equation. Input will be highly educated. Means education, you are saying that will be an input, right? Others? Okay, output will be salary. Perfect. और कोई आइडिया कि इसमें इनपुट आउटपुट क्यों क्या हो सकता है? अगर एजुकेशन सैलरी में एक रिलेशन बनाना है तो उसमें इनपुट क्या हो सकता है और आउटपुट क्या हो सकता है? और कोई? Okay, let me tell you. Mr. Ashish, the answer is correct. Input will be education. Why? We can say that if I have a higher education, then my salary can be high. I agree for that. Income can be high. But my education cannot be output. I am saying I am earning a high salary. I am earning, my income is high, then my education is also high. It is not true. You see that so many uneducated people have a big company and big business, right? So when you are choosing your target and predictor, you have to confirm, you have to do analysis, and you have to find out what will be the output, what will be the input. So in this case, education cannot be a output. That is totally wrong. Because I can't say that if I have a high salary, then my education is also high. But I can say if my education is high, then salary can be high. But my inputs only not dependent on the education. It depends that in which city I am working. Maybe I'm in Bangalore or in Delhi or in Meerut, right? Or maybe I am in working in UP, Mathura, Lucknow. Depends on the location also. We have to provide the locations also where I am working, right? That's also important. And what kind of companies are there? It depends on that parameters also. So that also we have to take in the consideration. For example, in this case, I have used input as a rated horsepower, but we can include weight of the vehicles also. When car is heavy, of course mileage will be low, right? That is also very important. And what kind of model of the car is, it depends on the model of the car also, right? So we can use that also as an input. So that's very important when we are going to do. So like this, we can create a multiple fitting for the car if it is driving in the city, car driving in the highway, truck city, and truck in the highway, right? So like this, we can create a multiple fitting curve, different fitting curve. Okay, this was about basic data analysis in MATLAB. How we can do analysis and how MATLAB can help, how Live Editor can help to do this task, right? And you see here, if I go in the tasks, there are some data pre-processing options also. Let's say that I have to remove the missing data. If I have missing data, or outlier option is also available. Just I will click on this, a template will be generated here, right? And we don't have to write a code here. Just have to select the variable in which we have the missing data, and that missing values will be removed from there automatically, and it will be saved here. So instead of writing code, we can use template. And I want to see what is the code behind that. Simply I will click here. I can see what code is running behind that template, right? Field missing to fill the data, right? So we can use live script for the data pre-processings also. And if I go in live editor again, let me remove this part. And if I go here in live editor, if I go in the tasks, if you have to join multiple tables or time tables, there is a templates available for that. If you are going to use optimization, you can use this optimization template also. These are the new features in the new MATLAB. It was not in the previous one. Okay. And here you see there is one more template available here. If I go here and if I go again in the task, create plot. Instead of writing code, we can use this template to see our data in a different kind of plot, like stem plot, stair plot, pie plot, bar plot, right? So just only we have to select here what kind of plots do we want, right? Simple plot, just I will select that and it will give us the simple plot here. So there is an option. Right, there's a contour plots. From here also you can select that what kind of plot do you want, and just provide the x-axis here and provide the y-axis here. That is my list, and we'll get that plot here. Right, this is a plot. Right, I don't want line plot. Let's say I want some different plot, so here we can choose different plots also available. Statistical visualization, right? So we can use these templates to visualize our data in a different form. I am going to close this. Do we have time for 5 minutes more? So I can show you how to design an app in MATLAB. Have time, sir? Okay,
Okay,
just
sir.
5 minutes. Yes, sir.
Okay, sir. Continue, sir.
Okay. Let's say that I want to design the app and I want to share with my colleagues. To design the app, to create a .exe file, we don't require to know the Java or C++. In MATLAB, very easily we can do. To do that, simply we have to go in the app, in home, in new. There you can see there is a app designer. This is a new feature, new way to design the app. In older version, there was a GUI, graphical user interface guide. It was called. Now we have new feature, that is app. So a new window will be opened here. We can use this app window to design our apps. How it works? Let's start from the blank model. So we have a short time, very simple equation. I will show you simple designing. So first of all, here we have tabs available, right? Access if I have to plot, and if you have to click on something, then button is available there. Data picker is there. Calendar drop down menu is available there, right? Somebody is working on aerodynamics, so we have libraries available for aerodynamic. Like if you want to indicator for air speed or altimeter, right? Horizon, right? This kind of blocks are available. See, in our case, what we are going to do, we are simply going to use the axis, fine, and one slider. Here we have this slider. What I am going to do, one equation I will create here, and when I move the slider, equation frequency will be changed, and once the frequency is changed, my figure will be also changed. Means based on the frequency, what kind of figure we are getting. That's very simple. We are going to plot it here. So this is my slider here, right? Now, this is the design view which you see right now. And here you see that automatically some codes are generated here. Perfect. Okay, now I want to change this slider minimum maximum value. So here is the option. You can provide the limits of that, right? And how this slider do you want? Like this, vertical or horizontal, that also we can select that. Perfect. Now I want to move this slider, so figure will be changed. So what I'm going to do, just I'm going to select this, right click, and I will go in the callback, remember, and add value change function callback. Okay, I'm going to create this, and here you see that one slider is created, one function is created. Here I will write the equation. Let's say that I have uh, frequency is equal to, let's say this is my frequency, this value which I am getting, this is my signal frequency. Okay, so any data which will be saved in the access or a slider, it will be saved as a app. Okay, So this is the slider. So app dot slider dot value. Let's say this is the frequency. Now we are going to define the time. Let's say 0.0125. Okay. This is my time here. Okay. Now we are going to define the y. Let's say y is cos 2 into pi into this f and into t. And f from where it will get? It will get from the slider. Perfect. Now we are going to plot. In this case, when you plot, we have to define the axis. On which axis are you going to plot? We have one axis available here, right? This one. I will just simply go in the code view and plot. First define the axis. The axis name is given. You don't have to remember, right? So app dot UI axis, and what I am going to plot t comma y. Let's check this app. I'm going to save this app first of all. Let's say that this app's name is my app. I'm going to save. To check this app is working properly or not, just I will click on run. Okay. Now the value is 0. So we are getting nothing. Let me change this slider. And you see when frequency is 40, this is the graph. And when I decrease this is my graph, right? And there is an option also, if you want to print it or if you want to see some value or if you want to zoom it, you can zoom it also from here, right? There is an option available. Okay, and if you want to format this, there is an option to brush the selected data. So there is an option, you can brush it like this, right? And let's say I want to share this app with my colleague who doesn't have MATLAB. Okay, so I check my slider is working fine. I will go in the designer. I will go in share option. Three kind of apps we can generate. MATLAB app. If I select, then this kind of apps will be generated, which we can deploy in the MATLAB itself. This kind of apps. Okay. Second is web app. Web app is used to host your app on browser. If you want to host your apps on browser, you can select web app. If I choose a standalone desktop app, it will create a .exe file and it will run on the window and I can share with my colleagues. Okay, so once I will select this standalone desktop app, a compiler will be opened like this. Here you can provide your name. Here you can provide your icon. You can provide the version of that, email, company, summary, everything. And just I have to click the package. Once I will click this package, it will create a .exe file. So why it is doing? Let me move to PPT here. So you saw that we saw how to import the data from file, how to do pre-processing. Then also we saw how to develop the algorithm, how to share our algorithm as a PDF file or doc file, that also we saw. And further we saw how to create an app also, right? And if you want to do advanced data analysis, you can explore machine and deep learning also, or you can use different file, text file, binary file, audio, video, image, or if you have a web services, you can extract data from webs also. You can generate library for other languages also, right? You can access data from hardwares also, right? For exploring, we saw manipulation, pre-process, managing data, right? Visualization, we saw 2D and 3D all this. So this is a summarization, what we have done in this session, right? Further, we can share also, or if you want advanced algorithms to use, we can use control system, signal processing, image processing, parallel computing, depends that on what kind of applications are you working with. And we can publish MATLAB files as a doc file. We can package our app as an application, that also we saw here, right? Now, the next thing which I wanted to discuss, how you are going to learn MATLAB and to get the certificate, which is free. So I'm going to share you the link. Just register on MathWork website. It is free. Okay, once you register, and these are the courses for basic MATLAB, Simulink, machine learning, deep learning. These are the 10 free courses available there. Signal, state flow, Simulink. Once you complete this certificate course, you will get the certificate like this. Like I have done, and I got the certificate. And you can use the certificates in your resume also. So that will be beneficial for you. And there is no time limitation. You can start, you can pause it, and you can start from the same where you pause. Okay, so I'm going to share this link, and this is free, and you can register here freely, and you can start the courses. Only maximum every course is of 2 to 3 hours only, right? Get the certificate. I will suggest more if you want to learn about MATLAB. I have MATLAB for beginners YouTube channel I have created here. So if you want to explore more, you can visit on this recorded webinars and videos, and you can explore more. And whatever the session we are doing today, that video also I will share that. Okay, so let me check that app is created or not. So it's taking little time. It will be created as a .exe file. So maybe I have created some apps here. Let me check. Okay, so yeah. Okay, let me open that. So let me show in the Explorer. Okay, so once that app is created, you will get the .exe file like this, and you can share with anyone. They can access that .exe file. Right? Okay, this one is also created. So now you see that I have created a .exe file for that app. So it doesn't require a MATLAB. Okay, and we can run this app like this. So if you have any questions right now, you can ask me. That's all for the session today. So we saw basic 2D and 3D mathematical equation modeling and plotting. We saw how to import data, how to do different kind of analysis, simple mathematical equation, how we can create, how we can fit our data. That also we saw. We also saw how to create and design apps, and how we can convert that apps as a .exe file, standalone applications, right? And we can share that apps also. Perfect. So that's all. Any question you can ask me.
Kindly ask.
So every students, you have a time, you can just visit on this mathworks.com, and you can start doing these courses also. So that's very important. If you know other languages right now, if you want a good job, it is very important to know a multiple languages, and depends on your application area. If you are working on data science, you require to know C++ also. That is very important. You require to know MATLAB also. You require to know Python also. So one more software knowledge will be included, and that is available free for you, right? These courses, just start doing that.
Thank you, sir. Thank you so much, sir, for this session. Now I request